Open your phone today, and algorithms seamlessly curate your feed, draft your emails, and even predict what you're going to type next. While these tools feel modern, the concepts powering them are older than you might think. They began over 70 years ago. In the mid-20th century, mathematicians like Alan Turing began asking a very specific question: could we build a machine that could think? A few years later, in 1956, researchers gathered at a conference at Dartmouth College and gave this pursuit its official name: artificial intelligence. What we experience today is the result of decades of patient academic work, step by step. For a long time, progress stalled completely. These long stretches of stagnation became known as the AI winters. The theories were brilliant, but the physical hardware of the era simply couldn't keep up. The computers were too slow and their memories were too small. The thaw finally came when two massive shifts happened. First, the internet generated enormous, globally accessible pools of data to train these systems. Second, physical computing power caught up. We built vast, highly efficient server networks that could process all that information. Now that the engines match the blueprints, these tools are suddenly everywhere. To use them well, we need a clear way to organize them in our minds. The easiest way to understand these concepts is to picture a classic Russian nesting doll. The largest outermost shell represents artificial intelligence. Think of this broad layer as the basic goal: getting a machine to perform tasks that usually require a person's judgment, like identifying an object in a photo or deciding which email is spam. In the early days, this meant humans manually wrote thousands of highly specific if-then instructions. If X happens, do Y. At this outer layer, the machine isn't thinking on its own. It is strictly following human logic. But if we open that shell, we find a specific, more advanced method nested inside. This is machine learning. Notice that machine learning sits inside artificial intelligence. It is a specialized subset of it. Here, programmers stop writing endless if-then rules. Instead, they feed the computer large amounts of raw historical data. By reviewing all that data, the machine maps out mathematical patterns on its own. It steps beyond merely following rules, becoming an independent system capable of recognizing complex trends. Finally, we open the machine learning doll to uncover the dense, innermost core: deep learning. Deep learning is an even more specialized subset resting inside machine learning. At this layer, the software uses an underlying system called a neural network, which is structurally inspired by the web of neurons in a human brain. These networks are designed to process massive amounts of unstructured, messy information, things like raw images, live video, and spoken human language. When you interact with a highly intuitive tool today, deep learning is the specialized engine driving that experience. Let's see how these three layers work in the real world. Imagine a factory floor with an expensive industrial machine, where an unexpected breakdown costs millions of dollars. With basic rule-based AI, we might program a simple instruction: trigger an alarm only when the gauge hits exactly 180 degrees Celsius. That works, but it is entirely reactive. Management is alerted only when the machine is already in danger of failing. Now let's look at this chart tracking historical trends. With machine learning, we feed the system 3 years of maintenance logs to find patterns. The system identifies the conditions that lead to overheating, predicting exactly when a failure is likely to happen, so we can schedule preventative maintenance. Finally, observe these audio waveforms and complex data streams feeding into our neural network. This is deep learning. The network listens to the machine and detects tiny, irregular changes in the motor's hum to anticipate a system failure days before the temperature gauge even registers a change. We evolve from reactive logic to predicting trends to achieving true predictive foresight. So, artificial intelligence is the broad concept. Machine learning finds patterns in data, and deep learning handles the complex, messy reality of our world. As a business leader, you do not need to know how to write the code for these networks. Your true value lies in properly diagnosing the specific problem your business faces. By understanding how these layers nest together, you will always know exactly which technological tool to open up to solve the challenge in front of you.